So welcome everybody. We have a very full agenda, so that's why I think I'm just gonna start. Yeah, welcome, good morning, afternoon, evening, from wherever you are listening or watching us. Today's webinar, we are looking at monitoring biodiversity at sea, and with a special focus on how this can be advanced in a nature positive way for offshore wind development. Yeah, I'm thrilled to see that there are so many people still joining. We had a lot of people registered, so yeah, still a lot of people in the waiting room, but I think we will just get started. First of all, welcome to GINGR. Welcome to our second biggest bigger webinar. This is a new kind of series actually, so I hope we have some followers who have already looked at the first webinar 2 weeks ago. I just briefly want to introduce myself. My name is Annika Liljestam. I'm the coordinator of GINGR, the Global Initiative for Nature, Grids and Renewables. I am on this call together with my colleague Aston McCaig, who is from the comms team and helping to facilitate this process, this webinar today. And we are guiding you through this webinar today. We have some housekeeping rules that we usually try to follow, so please rename yourself to name an organization. That would be really, really helpful to us to understand from where you're joining, which country you're from, etc. If you have questions, it would be great if you place these in the chat box directly, so we can look at all the questions together at the Q&A session at the end of this webinar. Also later you can raise your hand. We will have most of the discussion at the end, so just that you're aware, because we have so many presentations after each other that we don't want to have interruptions in between. And as you have already noticed, probably this session is being recorded, but this is mainly due so that people can have a look at the webinar at a later stage if they are interested. Please, it would be great if you write your institution and country of residence into the chat. This helps us to understand a bit what the target group of GINGR is on a global scale, because so far RGI has mainly worked on a European level, so this would be really helpful to us, and thank you in advance for helping us. While you are doing this, I am just briefly presenting our speakers. We have today on the call Dr. PJ Stephenson. He is an independent consultant working for the University of Lausanne and also being a specialist at the IUCN SSC Species Monitoring Specialist Group. And PJ has been working with us for quite a while, supporting RGI, but now also GINGR. And he's actually the author of one of our navigating papers, which he will refer to at a later stage as well. So welcome, PJ. Happy to have you here and excited to learn more in your keynote speech. Then hopefully at some point we will have Peng Zhao on the call. He's not in yet. He's an associate professor from the Hainan University in China. Then we have Christian van Slaus. He's a senior marine ecologist and project lead at the North Sea Foundation. So we will get some insights from the Netherlands. And we have Dr. Umberto Binetti. He's a marine biodiversity expert in the sustainability department at RWE Offshore Wind. Unfortunately, yes, we don't have time to introduce all of us. At the moment, we have around 60 people in the call. So thanks for writing where you're working and your names. This is our agenda today. I am currently welcoming you, and I will give a very brief introduction to GINGR so you know what GINGR is actually about. Then we will have the keynote as advertised by PJ on biodiversity monitoring, and he will be looking at challenges, opportunities, and tools. Then we have the insights from Christian from the rich North Sea, monitoring to advance nature-positive offshore wind development. After that, we are hoping to have Peng on the call to tell us a little bit on animal remote sensing. This will be sort of a little excursion. And then we are looking at the industry perspective with Umberto from RWE. And as I said before, we will have the possibility to have the discussion in the Q&A later in the last half hour of the call. So thanks all for joining, and yes, please sit back, relax, and maybe have some cold drink. I think it's quite warm wherever you are at the moment. What is this GINGR that I am mentioning all the time? So GINGR is a very new initiative, and it's a joint initiative by RGI, the Renewables Grid Initiative, which is an NGO based in Berlin, and the International Union for Conservation of Nature, IUCN. GINGR has been officially launched at the COP28 in Dubai in 2023. As I said, we're currently located in Berlin, but we work very closely with the colleagues from IUCN. And we are going to be a platform of stakeholders, many different stakeholders and experts representing the industry, academia, civil society. And we want to work with a very open mindset and collaborative mindset to integrate as many interested people as possible. And why are we doing this? Because we think that GINGR is really on spot at the moment. Just for those of you coming from a global perspective, from a global background and have not heard about RGI, I just want to briefly show this slide, also showing where Essen and I are working. So we are called the Renewables Grid Initiative, and we are quite a unique collaboration of NGOs and transmission system operators, basically bringing these two sometimes confronting parties on one table to find common solutions. And you can see all the members here on this slide. But why GINGR now? Why did IUCN decide to team up with RGI on this very specific topic? So we are all aware that we are currently facing a triple challenge. So yes, there is the climate change. So we all really need to invest in renewable energies and especially in grids at the same time. And at the same time, we know that the biodiversity loss is happening. There's a biodiversity crisis as well. And how can we hold and restore this loss? And last but not least, we also need to consider the communities that are involved in this process. So we need to have a look and talk to communities, talk to people, prioritize the needs that are the needs of the people that are impacted by new grid developments usually, and by new renewable energy infrastructure developments. So this is the background of GINGR. And what are we actually doing? We are currently working on a very comprehensive framework that will allow energy actors to report progress towards biodiversity gains and community benefits. This is a very ambitious tool. It's a very ambitious target to do. We want to have a monitoring and reporting system that can be standardized on a global level and that can facilitate the work of governments, of the financial sector, of the energy sector, and it should be comparable. And when I say this, we mainly look at renewable energies, meaning wind, onshore and offshore, and solar and grid infrastructure. So this is what we are currently focusing on. It is a very ambitious task. And this is why we work together with certain technical working groups. We have the metrics working group, which is led by IUCN. Then we have the Offshore working group, which is led by Ocean Conservancy. We have the Linear Infrastructure working group, which is concentrating on frameworks for terrestrial work. This is led by RGI, so by my colleagues. And we have the People Positive group, which is very new. It's currently being built up, and it's led by the Stockholm Environment Institute. And further down the line, we are planning a monitoring working group and a reporting working group. If you have more questions about GINGR, I'm very happy to answer these in a separate discussion, you can send an email. If you are interested to join us in one of these technical working groups, please drop us a line, because today we don't really have much time because we have a very interesting agenda lined up. But this is how you can get in touch. Have a look at our webpage at gingr.org, write us an email, and we're happy to facilitate bilateral calls as well. And with this, I'm going to stop sharing my screen And as you can see, GINGR is looking at working out metrics and that can help measure the impact of offshore wind on biodiversity. And I'm now very excited to learn more about how biodiversity monitoring can support the advancement of offshore wind development in a nature and friendly way. So first of all, thank you, PJ, for already sharing your screen. Yes, you have been working very deeply into this topic. So without further ado, I would like to give the word to you and looking forward and to learn more.
Thank you very much, Annika, and it's a great pleasure to join this meeting today. So what I'm going to be doing now is to give everybody like a big picture overview of the issues around biodiversity monitoring around offshore wind energy installations. And then, as Annika explained, the agenda will follow up with some experiences and case studies from people doing some of this sort of work on the ground, so to speak, or in the water. Anyway, let's start with the basics. I mean, I think as many of the people on this call will know, offshore wind energy is a vital component of global strategies to tackle climate change by increasing the use and availability of clean and sustainable sources of renewable energy. However, like most human activities on this planet, the construction, operation, and even the decommissioning of wind turbines and their associated submarine power cables and grid infrastructure can cause environmental impacts and threaten biodiversity. The good news is that these pressures and impacts on nature can be avoided or minimized if suitable approaches are taken. So, for example, with appropriate integrated maritime spatial planning, wind farms can be placed in areas that avoid sensitive wildlife and habitats. Construction can be carried out in such a way as to reduce the noise and pollution that affects different species. And turbines can also be placed and operated in ways that reduce the chances of, say, striking birds or bats. Increasingly, we're also seeing efforts around wind farms to actively conserve or restore nature, such as providing habitats around the infrastructure for, say, fish and crustaceans, sometimes known as like fish hotels, and also work on things like restoring oyster beds. However, in order for offshore wind energy to avoid and minimize these impacts and also conduct active conservation and restoration work, we need data. We need data on marine fauna and flora in and around wind farms and above and below the sea. So then we know where the animals and the plants and the corals and all the other organisms are, and then we can plan and act accordingly. But that's where we've been running into trouble, because just like with biodiversity monitoring everywhere, there are a number of challenges that prevent many of the wind energy actors getting the data they need. And just a quick overview, I mean, obviously the marine environment itself is a challenge. Many of the species are small and live underwater. Ocean conditions are also frequently not that favorable for detecting species, and especially imagine in high seas or strong rain. And also the different pressures on nature need to be monitored vary. So for example, they vary between taxa. So mammals tend to be more impacted by the noise from construction, whereas birds tend to be more at risk from collisions with operating turbines. Different stages of operation also affect it. So construction is often the point where you see potential loss of habitat. But again, obviously, things like bird and bat strikes are only going to happen when the turbines are operational. Also, the design and type of technology used is also relevant, and whether it's different sorts of turbines, whether they're bottom fixed or floating, that affects the impacts, as does the type of grid, whether it's a meshed or a radial grid connection. So all of these factors actually put different pressures on the environment that need monitoring, sometimes in different ways. And also, the methods used to collect data vary quite considerably as well between sites and between countries. And although in an ideal world we would share more data, people just cannot often access the data from other people or even learn lessons from others. So there are a range of different challenges out there, but that's why working with my colleagues at RGI in recent years, we've tried to overcome some of these. First of all, back in 2021, I produced a report looking at biodiversity data needs and monitoring protocols. And then at the end of last year, working with GINGR, we've now converted some of the key lessons from that into this discussion paper or navigator. And you'll get the links to that in the chat very soon as well. And what I'm basically going to do now for the next 15 minutes is just run you through some of the top line messages from those documents. Okay, I think first of all, when we're talking about monitoring in the context of offshore wind, it's very clear that if we had a more integrated and standardized approach than we do at the moment, this would help us to both, well, to compare sites, to aggregate data, to study cumulative impacts, and also then obviously to use the data to facilitate proper planning and decision-making as well. And as we discuss in these documents, we think there are four main overarching principles that can influence how this is achieved. The first one, which I think is also the essential one, which I will come back to, is you need to involve key stakeholders from the very start of both planning and implementing biodiversity monitoring. And monitoring itself needs to be integrated to the very early planning of offshore wind developments. Also, it's very important that monitoring methods that are chosen are based on the indicators being measured and the questions being asked. That may seem logical, but we'll come back to that in a minute. It's also quite clear that this isn't going to happen without any investment in resources and capacity to collect the right data. And also, as I alluded to earlier, we need to get better at sharing and making open available the different data that are out there as well. So those are the principles. This is the diagram, far too clever for me to have developed. My colleagues at RG and I summarized my thinking on this in terms of the principles, but as well as the principles which we dig into, we also outline 5 major steps that, if followed, we think can help improve strategic biodiversity monitoring around wind farms. And I don't have time today to run through every single detail of this, but I'm just going to touch on some top line messages. And first of all, I think, like monitoring of biodiversity in any context, it needs to be goal driven. You're collecting data for a reason. And therefore, step 1 in our guide is to suggest that you need to be very clear on the scope and scale of the monitoring. And the scope can be thematic. It might be, depending on where the wind farm is, focused particularly on certain pressures or certain activities. It might have to focus on certain species or habitats, or it might have a geographic scope based on perhaps a certain national territorial waters or a particular sea basin, or a combination of these factors. But the key thing is that that scope is clear from the start, and then that's translated into the scale. Where are you actually going to collect the data? And this is often around a given wind farm or collection of farms and a suitable buffer zone. You also need to think of temporal scale, and again, that varies greatly. The norm, certainly in Europe, tends to be for monitoring 2 to 3 years before consent and around about 5 years after construction. But again, that varies, and to be honest, most indicators are best monitored throughout the operational life of the wind farm. The next most important element of being clear about your objective is identifying the precise species and habitats that you need to monitor. And this needs to be based on the ones that are most impacted by offshore wind development in that area, or those associated with the nature positive actions that are being put in place to mitigate impacts or restore and conserve biodiversity. And then, I mean, essentially, a lot of what we put in the document after that is the essentials of what we need to think about when you develop a monitoring plan or a monitoring strategy. And this is not rocket science, and literally the basic elements of any monitoring plan need to be very clear about the what, the how, the when, the who, and the where. So that is basically defining the indicators, the methods, the timing and frequency of data collection, who's responsible for the data collection, and the precise locations the data are going to be collected. So when we think about indicators, most biodiversity monitoring, for all the different reasons you need it around a wind farm, will tend to include measures of biodiversity state. That's usually around the occurrence or abundance of different species, the extent of different habitats. There will also need to be metrics on pressures on biodiversity, whether it's noise, pollution, invasive alien species, and then all the various activities, whether it's around construction or the mitigation and restoration measures. So there might be metrics around the mussel beds restored, or incidents of stop on demand when it comes to operations. Now, once you've established the key indicators, you need to think about the methods and the data sources. And in the guidance note, we do in an annex provide quite a neat list of some of the global and regional data sources that are out there already with marine data of use. But now I'm going to focus a little bit more on the methods. And again, you know, with biodiversity monitoring, we've come quite a long way. Traditionally, the way you monitored nature was you went out to look for it, whether literally physically on land, on the water, or under the water. You went to physically look for it or possibly even capture it. But in the last, say, 2 or 3 decades, there has been an explosion in the number of different methods and technological solutions that are available for biodiversity monitoring. And let me just run through some of the ones that are most relevant now in terms of marine and offshore wind. Now, grab sampling and related core sampling are methods that are frequently used to assess organisms on and in the seabed. As you can see, this is an older technique. Even some of the photos are in black and white. But essentially, this is still, although it's a fairly basic method, you scoop up and see what you find on the seabed. This is still an important method to see what's going on in a number of habitats. But also, when it comes to looking especially for birds and mammals, traditionally, there's been a long history of surveys based on vessels on the water and also from aerial surveys in aircraft. And increasingly over the years, these have been supplemented by also turning the aerial surveys into digital aerial surveys with cameras, and also having various sensors attached to the ships as well. Also, a number of cameras have been operated under water and over the sides of vessels, and increasingly those are being deployed with autonomous underwater vehicles, which are also allowing access to places that previously divers or over-the-side cameras would not have been able to reach. A technique that has, I think it's fair to say, originated essentially in Australia, but is now becoming more widely used, is also baited remote underwater videos. And that's where video cameras are placed under the water, but with bait that then attracts the pelagic fauna into those sites. And that's proving very useful at identifying the presence of species that are less easily found with some of the other methods as well. Passive acoustic monitoring is now being used in a lot of environments, but it essentially started in the marine environment. A lot of early passive acoustic monitoring started by looking for and that is carrying on today. And we see around a lot of wind farms things like these buoys, sometimes called sea pods and variations of that, which are placed in the water and which detect the sounds from dolphins, sometimes even seals, sometimes either other organisms as well. And again, increasingly, this passive acoustic monitoring sensors are also being deployed either in towed arrays or on UAVs as well. The other technique that's really taken off, this one probably mostly in the last decade, is environmental DNA. Now, this involves essentially taking samples of water and then analyzing it in the lab to extract the genes from, or the genetic material from different organisms found in the water, which can give you an idea of the sorts of species that you find in the water. And we're now increasingly seeing that used as well to try and detect the presence of various organisms as well. So with all of this array of options available, I mean, and this is what I get a lot from people, is, well, how do we choose, given that we have so many options? Well, I think that there are a number of criteria that we specify in our guidance. I mean, first of all, you have to choose a method that's relevant to the questions you're asking, the indicators you're measuring, and the species and habitat. So, I mean, an obvious example, you wouldn't use an aerial survey to monitor fish or crustaceans. Likewise, you're not going to do an eDNA analysis to count the birds. So it really needs to be tailored to what you need. It also obviously needs to be feasible and reliable to produce data in the conditions. It also needs to be within your budget. And although it might be really cool to get some sort of drone or fancy eDNA analysis, maybe in fact the budget and the capacity of the actors concerned doesn't make that such a viable option. So you need something a bit more cost effective. And of course, as we're all aware as well, national and regional standards, policies, or legal requirements also will influence a bit what's measured and how. But ultimately, in every scenario, you have to weigh up the pros and cons of the options available. And again, especially in that earlier report I mentioned, we produce a whole series of tables looking at some of the advantages and disadvantages in different methods. So for example, here we're looking at vessel-based surveys, which, you know, some of the pros are that it actually allows you to estimate absolute or relative density and abundance using well-established and robust methods, but it can be expensive, it can be restricted by weather conditions, and it can disturb the animals sometimes as well. So just a snapshot, but again, every method has its pros and cons, and these need to be weighed up. Also, and I'm not going to go into this in detail, but there are a lot of standardized protocols out there explaining very clearly the processes that are needed to apply certain techniques. And if following some of those standardized protocols can also make sure the monitoring is of a certain standard. The other point to keep in mind is, while there are pros and cons in different methods, frequently you don't need just one method, but you need a combination of methods. And there's quite a lot of evidence that using multiple tools can increase the detection of animals or plants, or increase the number of indicators that you can measure. So just give you a quick example from this study in Canada, which looked at 3 different methods for surveying cetaceans. It looked at marine mammal observers on ships, also the infrared cameras on the ships, and also some passive acoustic monitoring devices. And when they were used in combination, these detected more species than when used separately. But in certain conditions, like in high seas or when there was a lot of precipitation, the acoustic monitoring or the observations were the most effective. But at night, the infrared also kicked in as a useful supplement.
PJ, you got 2 minutes.
Yep. And so just to literally my last point that I just want to raise in terms of design considerations is, as you think about how to monitor, it's always good to look at counterfactuals, so to look at reference sites. So I'd just say, here's an example looking at a particular marine bird. The site here in gray and the data in gray is the abundance of this site, this bird in a control environment. And the dots in green are the abundance at a site that was going to be protected. And so the data before and after the dotted line show the difference after protection. And because the organism increased in the site that was protected but remained stable in the control site, it gives you a stronger inference that your actions led to the change that you see. So considering counterfactuals at reference sites is also always important. And then just to finish, it's very important throughout, as I said, there are lots of global and regional databases on which you can share different data, but the key throughout is the data are then used. You're not collecting it for no reason. You need to actually use it. And so it needs to be for informing planning and adaptive management, also for adapting your monitoring systems, and also for many companies to help with biodiversity disclosures as well. So that essentially is my summary of what we found. I think going forward, there are a few knowledge gaps we need to fill. We need to look in a bit more detail about some of the impacts on nature we don't understand so well, and the efficiency and effectiveness of some of these monitoring methods. But I think in closing, I'd just like to highlight our other key point from this, which is that I think ultimately enhanced regional and sectoral collaboration on standardizing our approaches to monitoring, that ultimately is what's going to make a difference, because with greater teamwork and partnerships, that is going to be a key factor in ensuring that we improve monitoring and ultimately improve the status of biodiversity around offshore wind farms. So thank you very much.
Thank you so much, PJ. I think that was a great overview, and we got some good examples to see what monitoring biodiversity could look like. I think I would just like to move directly to Christian. We're still waiting for one of our speakers, so I hope during the time he will arrive. So please, Christian, the floor is yours. And we are looking to learn a little bit about some examples from the Netherlands and the North Sea. So you can dive a little bit deeper into what PJ has already elaborated on a more global level. Thank you.
Thank you, Annika. Well, I'm Christian van Sluis. I'm a senior marine ecologist working at the Rich North Sea program, which is an initiative of the North Sea Foundation and Foundation Natura Milieu, which is another environmental NGO. And we are now working on the Rich North Sea program for 6 years and have some practical experience in offshore monitoring in relation to nature enhancement. So first, I want to zoom in onto this overview, because offshore wind comes with a lot of effects, as PJ also mentioned, and I think there are 3 very important areas with regard to nature positive impact. We've got this negative effects of offshore wind, we've got the risks and unknowns in the middle, and we have the potential and known of positive effects of offshore wind. And only if we understand them, avoid and mitigate the negative effects, fill in the knowledge gaps, and really take the potential for positive effects of offshore wind, we can make it nature positive, but only if it's a full picture. So there are different programs in the Netherlands focusing on effects of offshore wind on nature, and there are state programs which I want to mention. It's the WOZEP, the Offshore Wind Ecological Program, which mainly studies the risks of offshore wind, and the MONS program, which is the Monitoring, Research, Nature Restoration and Species Protection program, which also dives into the many unknowns. And then next to that, there's this initiative of the Rich North Sea program, studying the potential for nature enhancement. So our vision is nature positive offshore wind, and that means that we want the net impact of offshore wind to be positive. So we don't only work within offshore wind farms, it's also fine to work with operators in other areas to compensate potential negative effects as well. So we're not area bound specifically. Our mission is to integrate offshore wind and ecosystem restoration on a wider scale, and we work cross-sectoral, science-based and scalable. This is an overview of our current projects. We run about 7 offshore projects. I don't have the time to dive into them all, but we work on water replenishment holes, artificial reefs, lobster hotels, and we have an offshore test area, and we work on oyster hatcheries for scaling up, and we have some other offshore projects. Today I will dive into our Gemini Winor project, and I want to mention here that you have kind of different kind of monitoring. We have this national state monitoring programs, monitoring the sea on a wider scale every 3 years. But the monitoring from the Rich North Sea program really focuses on finding thresholds for to then support nature restoration or nature enhancement. So the Gemini Winor project really aims to find thresholds for self-sustaining oyster reefs. That was the project scope. And for that, we zoomed in to seabed changes, so sediment changes and hydrodynamics in relation to critical survival cues for oysters. So oyster feeding, survival itself, growth, reproduction, and then to make the circle complete, also oyster settlements. Because if they can do those 5 things, they can survive and it can be self-sustaining. Really important bottleneck in that was oyster stability, because the North Sea is so dynamic, very high wave action. The question is, can we create enough stability to create self-sustaining oyster reefs? And so therefore we looked in oyster stability and substrate stability, and below you can find a general setup of our study. The squares resemble the 4 monopiles in which between we put heaps of substrate with oysters on top, which you can see in one of the pictures. And the special thing was we wanted to test if the oysters were stable on the seabed, and therefore we installed a tracking system so we could real-time follow oyster movements and then relate it to weather conditions, wave conditions, currents, sediment loads, for which sensors were all attached to this giant monitoring frame. So we could relate what happened to the oysters to the weather conditions and the field conditions. And well, I need to say here as well, before we designed this study, we really dived into the models and monitoring data already available on this site to find the optimal location and the optimal design. On the right below, you can find you can see a picture of a way to monitoring the feeding behavior of the oyster. So we could also see under which conditions feeding would occur. So what we found that the setup of coupling this abiotic sea conditions to the oyster biotics was very interesting, learned us a lot. Unfortunately, we lost lots of oysters. The weather, the site conditions, although the modeling said it would be viable to leave oysters loosely laying on the seabed, it turned out that the current weather conditions were too harsh. So we have to look for better substrate stability to make self-sustaining oyster reefs work in this area. And that's part of the results. You have good models, you have good plans, good logistics, and then you have technical failures, human error in the field. So it also comes down to your experience in actually doing it in the field. So it's not only science, it's also doing it and learning by doing, and then optimizing your approach. That's really what we experienced. And also vessel availability it's not always there. Another project I quickly want to highlight is the Be Wild project, in which we work with Fugro, Wageningen University, Mikal, Seekable, and Crosswind. Those are really offshore parties, and the aim of the project is to integrate ecological monitoring into the technical monitoring of offshore wind farms. And I think there's great opportunity. If we can standardize those things, that would be a huge step forward, because all those offshore wind farms, they are already monitored. They have to monitor their assets regularly, and they already go down with an ROV. And if you could add on eDNA or grab samples or other monitoring techniques to those events, you would have a lot of more data already integrated with the asset data. And your biggest win may be your planning, your health and safety, and your costs. So we're really working towards making it work. And also, we experienced that there is a lot of enthusiasm towards biology in the technical field. So there's lots of potential there. Then one of my last slides. Other opportunities for monitoring. In the Netherlands, we've got nature-inclusive tenders. So for the licensing procedures of new offshore wind farms, they are tendered, and they have different steps. And the steps are kind of general. reflect also the process in other countries. But this is the Dutch step. So first you have got the area selection by the government, and they do the general monitoring on forehand. In the preparation phase, they do more monitoring, like the geographical monitoring. And I think that's another opportunity to integrate the technical monitoring with the ecological monitoring. And then the following phase is the tendering phase, where in the Netherlands you've got non-price criteria, also on ecology. So they have to put down a plan to on ecology, to strengthen ecology to win the tender. And I think the plan must hold the technical design for the strengthening the nature, but I wonder if it also already sets out the rules for how it should be monitored afterwards. And that's also, as soon as the wind farm is operational, you've got these environmental measures from a legal perspective that are obligated. And I think also there in the side decisions there could be monitoring guidelines how to follow up on the plans presented and who won the tender. So lessons learned, opportunities. I think the greatest opportunity for monitoring around offshore wind farm is to integrate ecology with technical surveys upfront in the site survey and the tendering, but also during the operational phase, asset monitoring and maintenance. And in that, we need the standardized procedures PG was talking about. I also want to mention we are right in an industrial revolution with regard to monitoring. We can do so much more than we could before, and it's really great what we can do, how we can integrate different monitoring techniques, and how we can now show the underwater world to the wider public. So I think we should really take that chance. That's what we are doing at the Rich North Sea program. This is a quick overview of different projects and missions. And I want to present also here the toolbox of the Rich North Sea program, in which we summarize all our projects, monitoring activities and results. So please take a visit. Contact us if you would like to learn more or collaborate. And we are very open to learn from other projects as well in the Netherlands, but also abroad.
Thanks so much, Christian, also for staying in time and very insightful pictures and examples, actually. And if I can just follow up with one thing, because I mean, PJ has presented this big array of methods out there, and in the North Sea, offshore wind has been for a long time, and I guess Netherlands and Denmark and some other countries are the ones with the most experience. So if you could say, like, from your point of view, which methods have proven to be the most effective ones so far? I mean, I know there's no generalization and every place is different, but in the North Sea, which biodiversity monitoring methods could you say are the most not only cost effective but effective in general?
Yeah, so it really depends on your research goal. I think in general, for the general impression of what your change is in the environment, ROV and eDNA is really cool, and we do it within all our projects. But if you really want to go further in optimizing nature restoration techniques, we dive into the bottlenecks for those techniques, and then you need the tracking, far more detailed monitoring techniques. So there's a general monitoring, and then there's underneath there's more specific, new, innovative techniques you need to get further.
So it's constant learning processes, basically.
Definitely, yeah.
Thank you. And we will get back to all these questions later as well. So I invite you already to drop some questions into the chat box if they come during the presentations. And now I would like to welcome Peng Sao from Hainan University. He will do a little bit of an excursion with us on animal remote sensing in the Antarctic, actually. So as far as I know, there's not much of offshore wind there yet, but maybe we can learn from your experiences. And yes, we are very much interested to learn what you have to say and tell us today. So if you want to, you can please, yes, change to presentation mode, and the floor is yours. Hi, Peng.
Hello, everyone. I would like to give sorry. Hello. Yeah, right. Close. Okay. Hello, everyone. I would like to give a brief introduction about the animal remote sensing, which can maybe used not only in Antarctica but also in other areas. Actually, I start this presentation because the remote sensing, the very quick development of the remote sensing, not help us a lot. We can see the world from the heaven, not only the continent, not only the forest, but also even a tiny spot. Actually, I started this research when I will pursue a doctorate degree. I used the satellite remote sensing method to count whooper swan. Originally, in the common view, we view the bird from the land. Actually, it's very difficult to tell who is who, but from the heaven, from the satellite, we can identify the whooper swan individuals, and we design some method and use this information to tell the dynamic and the population size of the whooper swan, actually within 10 years and in breeding season. Actually, the result is quite different from what we expect. The habitat changed. The total population is not so big as what we expected. So actually, this information lets us to think about this outcome. Lets us to think about. We can use this method. We can use the remote sensing method to map and to count the gregarious and uncovered animal populations in the world. For example, the penguin, sea lions, and white whale, and other maybe deers and flamingo, many kinds of animals. So I have an opportunity in Antarctica and to use not only the satellite imagery but also the drone imagery to map to count penguin in different gesture and the adult and crack and the trick. That is some example, and we count the penguins in different age, and yeah. And we also identify and to tell the, sorry, we also try to tell the social relationship of them. So we also use the satellite imagery to infer the distribution of the population dynamic in different year, yeah, and the telemetry, and use this information to inform our zoning. And we also use the AI to identify animals, not only the penguin, but also other animals. And yeah, this is an example to use the AI to estimate penguin dynamics in the Ross Sea in different locations. Yeah. Yeah, actually, I just gave a short introduction, and I hope to maybe to enlighten the biodiversity research for the offshore wind farm. Thank you.
Thank you, Peng. So I'm sure we will come back to some questions on this later because this was a bit fast. So I'm pretty sure there will be some questions to you later in the Q&A. And I'm also sure there will be room for discussion to discuss AI, which is a very sensitive topic at the moment. So interesting. And then we would like to start with the representation of the industry perspective from RWE. And I would like to give the word to Umberto, who is representing the sustainability department of RWE Offshore Wind. So without further ado, Umberto, the floor is yours, and thanks for joining today and making this possible.
Thank you very much, Annika, and thanks to GINGR for the invitation to give us the possibility of giving the industry perspective on monitoring. That, as you can imagine, is very important and is also part of the duties that we have in the areas where we are operating. Before going into the thick of it, I would like to just introduce a little bit RWE. We are an energy company. We are an energy developer. We have 130 years almost of history. We are headquartered in Germany. And we are in the middle of the energy transition. So obviously we have some operating technologies that are a little bit more legacy, like lignite and nuclear. But we are really much transitioning into the new technologies and into the renewable space. So we have our strategy called Growing Green, and we are going to become, we are at the moment the second operators in the world for global offshore outside of China, but we are in the top 5 for the renewable technologies like onshore wind and solar. And we also have operations in hydrogen, batteries, and so on. We think that the transition that we're doing in energy is also, it has to be done in a just way. We always call that the just transition. And this is why we have a quite solid strategy, sustainability strategy, that has 4 major pillars. So we have climate change, we have circular economy, we have local benefits, and we have biodiversity. Each of these pillars has specific policies. And today I would like to focus a little bit on the biodiversity because it's the one that is mostly related to the topic of monitoring and monitoring for the environment. If we look into the biodiversity policy of RWE, we see that we have several steps that we want to take. Through the mitigation hierarchy, we want to decrease the negative impact that we have on the environment, mostly through avoiding and minimizing the sources of the impact. We also have a commitment to become positive, to have contributing to have a positive impact on the biodiversity. But we also have to follow international regulations. So we need to do knowledge sharing. We want to report our progress and be aligned with topics and initiatives like the Science-Based Target Initiative for Nature, SBTN. In order to do all of this, we need data. We need to understand how much we are progressing with our effort. We need to understand how much we are gaining in terms of success for the positive impact, and we need to have data that we can report in the right way. So we need to do the monitoring in the right way, and again, monitoring is underlying everything we do. Now, you heard in the presentation from Peter about all the technical aspects of monitoring and why it's a little bit more difficult than probably on land to work on the sea. But there is one aspect that is quite important for the industry that has not been really touched upon, which is the regulatory framework, which is at the moment very, very fragmented. RWE is operating in a lot of different countries, and unfortunately, each country has specific requirements for the monitoring. And I'm here reporting only 3 of the examples of the markets that we are operating in. Actually, a 4th one is the Netherlands. So thank you very much, Christian, to filling one of the gaps that I had in my presentation. But if you look what's happening, for example, if you go to Germany, we have a very specific protocol, which is the STUK 4, that has to be applied to all the assets. And it's quite rigid in what it's mandating. So we need to use specific technologies. There are specific frequencies that we have to take the data at. And then in terms of data sharing, the data sharing is done with the regulator, but there are specific limitations to share the data with a wider public. If we move to the UK, the situation is completely different and is kind of similar to Denmark, in which the protocols and the monitoring is decided on a project-by-project basis. So we basically look at the environmental impact assessment that we do before construction, and then we need to suggest what to measure, how long to measure. And usually the measuring is up to 5 years after construction, because we think that the construction is the moment in which the maximum impact is happening. And then in terms of the data, while in Germany there are limitations, in the UK we must share all the data, and there is a platform that is managed by the Crown Estate, which is one of the regulators for the seafloor in the UK, and they have this marine data exchange where all the data are publicly available. So according to the market, we need to put different monitoring in place. We need to do the planning in a different way, and we also need to engage with different stakeholders. And this is obviously creating some problems, especially when we want to do some cost saving using standardization, or when we want to take lessons learned or best practice across all the markets. Because once we want to put all the data together, we want to integrate the data. The data are in a different format. They're coming from different technologies, so that integration is very difficult. So what we're doing, and the reason why we're here to present the project, is that we don't want to be immobilized by this the fragmentation. So we started a project called SIMI, which is stands for Sustainable Ecosystem Approach Monitoring in the Marine Environment. This is why we made it shorter. It's a little bit of a mouthful for a project name. And the idea is that we want to test how we can improve the monitoring in offshore wind. We think that we have to shift the paradigm. We have to go from what we are doing at the moment, which is measuring individual component of the ecosystem, to a system in which we put all this data together. We can integrate the data. And the goal at the end is really to combine, to have an ecosystem approach. So we want to understand how the entire ecosystem is moving, how the entire ecosystem is reacting to our presence in the environment. We think we can do this having some benefits, not just for the environment, but also for us, because we think that understanding holistically what is happening, we can check better what are going to be our measures in the future that we have to apply. And using new technologies, we can also reduce our invasiveness on the environment, and we can also do some better planning. For example, instead of sending more vessels, more flights, we can use our own CTVs, which are the crew or transfer vessels. And this will enable us to decrease the amount of CO2 that we are emitting in the environment, because we are, again, using less vessels and less other vessel and flights, sorry. And then the other thing is that if you're using remote sensing, we can also send less people, and that is obviously decreasing the risk. And as you can imagine, for a company, decreasing cost and decreasing risk is one of the big buzzwords that we are going for. And just to go very quickly, it's a big project, but what we're doing is testing an array of new technologies. We are doing this on the ground, so we have one of the wind farms in Germany where this is going to be tested. The project has started in 2024. This summer, we're going to have a massive campaign in which all the technologies are going to be tested at the same time. And then we're going to also integrate the data and share the data on a dedicated platform that we are creating. If you look here, you can see for all the components, we are trying to use innovative methods. And a lot of these methods, again, going back to what Peter was saying, are being already suggested as a possible way forward, but we need to test it on the ground to understand not just the scientific aspects of what we can achieve, but also from a logistic point of view, how we can use the technologies, what the technology is telling us. And very importantly, since this is done in Germany, where we have the STUK 4, which again is quite a rigid protocol, we want to use all this method to compare with the current mandatory and current regulations, and try to understand how the new technologies can bring us to the next version of the STUK, which potentially should be the STUK 5, which hopefully will have a lot of these new technologies. We're using eDNA, we're using underwater vehicle, we're using cameras above the water for the birds and below the waters for crustaceans and fish. We also have drones. We have quite a big drone that is going to substitute the flight. And what is important is we want to do everything at the same time, because we think that taking the data simultaneously is going to help us with that integration of the data that we want to do after. And obviously, there will be a lot of component of AI involved in this, especially for the image analysis that it's usually, well, historically, has been very, very long. And now with the AI, we can process a huge volume of data, a huge volume of images in a shorter time. We can do also AI for the identification of the species. And again, there is that effective management of the data that is going to be pivotal, because we're going to bring everything together, and we can also share the data with more people, because this is a new system that we would like to put in place. And as we said at the beginning, we want everybody to use more or less the same method so we can integrate the data. So this new system, we are piloting it, but the idea is that if it's work, will be useful if the entire industry is jumping on board and using it. As I said, the project is still ongoing. It started last year, but we have the major campaign this year. But despite that one, in 1 year of speaking with many stakeholders and speaking also with the rest of the industry, when we have presented CIMI around, we already have some take-home messages and some lessons learned. And I would like to close with these 3 major lessons learned that we have. We think that monitoring, yes, it has to be improved. We have done the best that we could until now with the technologies we had until a few years ago, but we really think it's the moment to use the innovations that we have in the market. These innovations are available. There is a lot of R&D that is going on. So things are going to become better, but even now we have systems that are way more advanced than what we had 20 years ago, or even 10 years ago. And we think that the protocols that are currently in place should allow industry to take full advantage of these innovations. Because as I said, they're also useful to reduce the costs, and they're also useful to reduce the risks that we have. So 2 major things that are very important for industry. The second part is the value of collaboration. CIMI is involving 6 external partners. We are really working with academia, with innovators, but on a wider scale, we need to have more collaboration also across the market, because we want a sea basin approach to understand the ecosystem. The ecosystems don't really follow the borders that the countries have, so it doesn't make sense to measure something in one country and something else in another country. We want to bring this collaboration together, and this will be very useful in a moment in which areas like the North Sea have seen a big build out of offshore structures, so the cumulative effects are becoming more and more important. And we think that the collaboration among the regulators and the users of the sea will be very, very fundamental. And the last bit is about harmonization. You heard this a few times already today in the previous presentations. We don't have an harmonized, we don't have a method, we don't have a standard methodology. And this is creating problem, because every time we want to roll out something through the entire portfolio that we have, we cannot do it because the regulations are different. Something that will be very useful is to have, at least on a sea basin level, these standards and maybe a core system, a core list of parameters that we should manage in a standardized way, so that we can pull all the data together. This also will improve the collaboration, will also improve the innovation, because the innovation will be targeted on specific metrics that we have to measure. The harmonization will also help us to do the reporting, because everybody will report in the same way, so the clarity will be improved. But we also think at the same time we should use the flexibility, because that local context, local species that might be particularly important are still also a priority. So we think an hybrid system, which with this core harmonized list of parameters and local parameters, will be very useful. And with this, I think I'm at time.
Thank you so much, Umberto. I already see some questions specifically targeted to you in the chat box, but I was expecting this actually. But can I follow up on one of the things you said, because the fragmented regulatory frameworks across all the markets that you are looking at, how can industry leaders like you, RWE, help to push more for this global or regional harmonization? Because you are a big leader in the market, you have some power, but on the other side, we still want to respect, right, the unique needs of the local ecosystems and the people living in those areas. So it would be interesting to learn what RWE thinks on how this can be done.
Well, it's one of the 3 points that I mentioned at the end, which is the collaboration. And we are part of, for example, Ocean, that is also led by RGI, in which we put together the developers with the NGOs. So we have the expertise on the environmental aspect, and then we have the industry expertise to suggest a new way, because we think that we can bring all the logistic aspect, and the NGOs and the academia can bring the scientific component.
Ocean is an abbreviation for the Offshore Coalition of Energy and Nature. Maybe Aston, you can please.
Yeah, we also like this
because there are so many abbreviations.
Yes,
people might not know Ocean. Okay.
And I think it's important, Annika, just to say that Ocean is this year starting this task force on monitoring. So we are realizing how much this is important to move forward.
Yes, and maybe just to follow up also with you directly now, because this is more a question. In which wind farm in Germany does your pilot project take place, the one that you just presented?
Is Kaskasi, and it's off Helgoland Island.
Okay, Helgoland is very up north in the North Sea and the High Sea.
Yeah, it's almost between, let's say at the level between Denmark and Germany border on the west side.
Yeah, and maybe, so there's also one question by Lisa Babak from Deutsche Umwelthilfe, and this is a question I think you get a lot, or we can also discuss it all together here. Is it really the regulators now it's been moving, is it really the regulators that stop you from sharing data, or is it more in the interest of the business to not share data? This is sort of a tricky question. Data sharing is sensitive, I assume, but you say you're already cooperating with others. So how do you react to this?
Yeah, again, it really depends by the individual markets, because if you go to the UK, we must share data. Like there is a regulatory requirement to put everything on this marine data exchange. And in that case, our work is much easier because we must do it. So there is no question, there is no limitations or calculation of cost that we have to do. It's something that is by regulation, so we have to obey in order to have the license to operate. In the other markets, some of them, there are some data that obviously have a commercial impact, and yes, the industry might be interested and is interested in reserving some of this data and giving some limitations to be shared. But sometimes we can do the sharing a little bit later in time. So maybe there is a delay in the amount of time between when the data are collected and the data are shared. But especially for the German markets, and if there is somebody from that market, from the regulators that has updates on this, please can you put that in the chat. But my understanding of the German market is that there is actual limitation from the government to share all the data externally. So we actually have external regulations that is blocking that.
Thank you. I also want to give the others the opportunity to say a little bit more on data if you want. I mean, PJ, you also mentioned, and you wrote it in the paper, data sharing is key. How can we all together here ensure that the data that is actually collected then also supports the decision making at the end of the day? That's something I'm interested. I don't know, I hope some others are too. I will look at the other questions also, but I also want to have the other panelists have a word.
So That was a question to me then, right?
Yeah,
Okay,
and then the others can fill in if they want.
Yeah, no, sure. Well, I think as Umberto said, I mean, one of the big challenges, and I've seen that a lot in some of the reports I've done for RGI, I've looked into the policy frameworks as well, and it is a really big challenge, not just on how different governments expect wind farms to be monitored, but there's also issues sometimes about where wind farms can be sited and how rigorous countries prevent them being constructed in protected areas and so forth as well. So it does create a big challenge for companies. It creates a big challenge for people trying to help governments and companies with the monitoring as well. But in terms of data, so data is always sensitive, right? I mean, at the moment, though, unfortunately, too much data is buried in environmental impact assessments or strategic environmental assessments, and it's not put out there. I mean, a lot of governments are starting to, as Umberto again had said in his presentation, make that an obligation that it's shared. But again, it's not happening as well as we would like. But of course, if we were to stimulate more sharing, I think there's always a worry in any sector. People are worried that what if the data we put out there shows something bad has happened? But the point is, you know, we're not going to learn if we don't look at trends and see how people responded to perhaps something that didn't go the way they hoped. So I think we need to get beyond the fear of having done something that isn't perfect, to actually more a fear of not learning from the lessons from that. And so, I mean, again, this is more of a culture as much as policy and legislation. But I think we do need to start seeing some of those national and regional efforts to set up databases expanded. Because as I said in my presentation, there are certain questions we can't answer if we're only focused on the site level. And it's ridiculous if data from, say, monitoring around one wind farm is not available to one just a bit further along the coast, because there might be data in that can be shared. And plus the fact, if you can actually start aggregating data across those sites, we can look at some of those cumulative impact issues as well. So there's no single solution, but it does go back to that issue of more collaboration, more discussion, less companies and countries sitting on their own and developing approaches without talking to others.
Yeah, Umberto, you can.
Yeah, I have 2 points about what Peter just said. One is, yes, we have the liability. So showing the data that could give us the wrong, what we think is a wrong perception of what's happening is an actual issue. And my second point is what my manager always tells us, that we are the last kid on the playground. We just arrived in a very, very overexploited ocean already, and sometimes the fact that we arrive in a moment in which the ecosystem is already declining might create that link between, oh, you see, you put a wind farm there, so there is less fish, without thinking about, for example, all the overfishing that has been happening in the last decades. And I think that harmonization might help us with both the aspects, because if we can take a regional approach, it will be easier for us to understand what is an actual impact from the wind farm and what is the general trend of the ocean. Because at the moment, if we only go on a side-by-side level, we might see a worsening of the condition in the wind farm, but it's actually a worsening of the condition in the entire sea basin. And right now, we don't have the data to say which one is which. And this is why there is also a little bit of resistance where it's not mandated by regulation of the industry to share the data, because we don't want the data to be used in the wrong way to attack us and to tell us that we have an impact that we don't think we have.
Christian, do you want to jump in?
Yeah, well, I see an opportunity in there as well, because you come into a degraded ecosystem and you might see recovery of some pressures within the offshore wind farm, because it's exclusive for some users. However, it reminds me of how difficult it was to do our first offshore project with Rich North Sea. Okay, you are an NGO, you want to do offshore work. Do you know about the health and safety regulations? And then when we learned to do it, the second project was easier, and thereafter it became easier and easier, and we began to exchange the experience between different operators. So I'm really happy with the project presented by Humberto. I think there should be first mover advantage in here as well, and just do it and show that it can be done, and others will come there. They will follow.
Thank you. I mean, now so far the discussion has been focused a lot on the European waters in the North Sea, and there are a lot of people from outside of Europe here, and I would like to ask you all what experiences, also looking at the fact that Europe is most advantaged with offshore wind so far, what experiences can be taken, and what are the major lessons learned that you would think could be interesting for markets that are going to start with offshore wind very soon, or sort of starting now? So, or which mistakes could be avoided, maybe perhaps as well? Anyone want to jump in on that?
We are sharing some internal knowledge because we are starting to explore the Asian markets where the regulations are less developed than in Europe. Mm-hmm. And what we see is that it's really at the beginning of the conversation in some countries. And this is something that we are trying to move, but at the same time, we have to take into account, and this is linked with some of the questions I've seen in the chat about the fact that monitoring is expensive. And, we're still in a very difficult market at the moment as offshore wind. As you know, a few peers have pulled out from some of the projects. So whatever we want to do additionally to the monitoring that is mandated, it's very difficult to be implemented, because we can promise we're going to monitor everything, but if the project becomes too expensive, we are not going to be able to build because we're not going to win the bid. So there is always a threshold that has to be achieved between our sustainability team and the actual commercial team. I think the lessons learned is that whatever is mandated will happen. So that central coordination done by the governments, especially also on sharing the data, is very useful. It puts the industry on a level playing field, because that everybody has to do it. So it doesn't become financial discussion anymore. And I think that is very useful. And also, again, the harmonization, just tell us more or less what has to be measured, and give us the possibility of investigating the innovations, like understanding how to do this in a more efficient way using the innovations. So yeah, I think that the take-home message is tell us what are the most important things to do and make sure that everybody's doing it, but also give us some flexibility to make the whole system more efficient according to the industry standards.
I would agree with Humberto, if I may, but I'd also just point out that I think we're at a stage now in the biodiversity crisis on this planet that we can't always wait for governments to mandate what needs to be done. We're seeing it now with this huge rise in populist governments. The environment is dropping rapidly down the agenda again, as are commitments to sustainable energy. They're falling off people's radar as security issues and so forth rise to the fore. So I think, and what we're seeing in environmental issues as a whole, is we cannot rely on governments. Overall, I think this has to be industry leaders need to step up and say, you know what, we haven't been mandated for that, but we are going to do that. And I know there are challenges to that, and I appreciate the competitiveness of there's always the argument, well, if we're too, goody on the environment, then the ones that aren't will get the contract. Somehow we've got to overcome that. But nonetheless, I think this is where we need some industry leaders who are starting to explore and act accordingly, need to be in some way also rewarded more broadly. But I do think I hear what you're saying about mandated, but certainly in the European Union and I'm sure in some other countries at the moment, we could wait a long time for that.
Yes, and since we have a representative from China here, maybe Peng, are you able to share some insights from China on regulations and the frameworks that are used there for offshore wind? Is that something you have been looking into in your work? Now I think you're frozen now. So maybe. Okay, then let's let's move, because I look at the time and there are still a lot of questions, and I see Ronan, is that how I pronounce it correctly? You have several questions, so maybe if you are comfortable with it, I can ask you to ask your most important question in
Hello,
person.
could you hear me? Sorry.
Yeah.
Oh, sorry. I'm so sorry. Could you hear me? This is Zhao from China.
Yes. Now we hear you. Yes.
Yeah. Actually, yeah, the wind power we see, I think it's exponentially increased in last 5 years, and now in the coastal province, the offshore wind was developing quite fast, and the government encouraged the offshore wind power. And as for the biodiversity, I think actually for the environmental impact assessment, there is a high requirement on the we call it EIA for the offshore wind power, but actually the science and technology is not enough to support the review the real impact of the offshore wind on the not only the bird but also the marine organism. So now the Ministry of Science and Technology and even the biggest wind power company is working, is trying to figure out a new method to promote the research of the wind power, offshore wind power on biodiversity. And my friends just talked with me about how to move forward the work. Could you hear me?
Yes.
Okay.
Thank you.
And actually, I know there's actually just in another city, not the city or your estate. Around here, there's a new offshore wind farm, and there are a lot of requirements for the environmental impact assessment, not even include the dolphin. Yeah, so I think they need to involve the discussions, especially, for example, the IUCN and the GINGR. Yeah, I think so. Yeah, your initiative, I think, to introduce more standard and experience to China, and to maybe to share some Chinese efforts to the world. Yeah.
Okay, so best practices is something that could be useful. I just have a look at the time, and there are still some open questions. And I saw that Ronan has asked several questions. So maybe if you're okay with it, I would give the word to you to ask. I think you asked one question already twice, so maybe it's easier if you do this in person. Do you want to unmute yourself?
Yes. Hello.
Hi.
Good afternoon. I had one question, because I'm thinking about, as offshore wind is rapidly being expanded, I guess, across the globe, throughout the world, are there any valid concerns to be considered or remediated related to disturbances to benthic habitats and undersea transmission cables, particularly those for offshore wind installations? Thank you.
Thanks. Who wants to jump in on this one?
Yeah, I think there are some. So what you've got with the offshore wind monopiles, you've got this marine growth, especially mussels on the surface on them, and they feed on the phytoplankton. And there are some models that in more stratified waters, the mussel feeding is so strong that you can actually change the inflow of organic matter to the seabed. So there could be benthic effects. Definitely, it could change currents and mixing of the water, and thereby indirectly the benthic community. However, it's very site dependent.
Sorry, Umberto, you also wanted to address this question.
Yeah, it really depends on the different technologies and different environments. So some of the cables, for example, can be put underneath the soil, like the seafloor. Some of them are just put on top, and then we put some rock bags on top. So obviously that is a very different type of impact that we have at different stages. And one thing that should be considered is the decommissioning at the very end, because all this cable, if they have to come out, whatever we try to create around a reef or like recreate a nice new environment, then when we have to decommission, that is going to be disturbed again. So I think also that decommissioning is something very important to consider, and we are only thinking about it now because after 20-25 years, we are only now starting to think about how to remove these massive infrastructures. And then there are some new type of impact from the cables, for example, the EMF, so the electromagnetic fields, and we don't really know the type of impacts and the magnitude of these impacts. So at some point, we need some better data to understand if additional mitigations have to be put in place.
Yeah, these are the knowledge gaps that are also mentioned in PJ's presentation and PJ's paper, actually very important. Looking at the clock, we only have a few minutes left. I would like to focus on one more question, and which is future trends. So there are a lot of methods available. You mentioned them. There's a big array. But what do you at the moment see are the major future trends around offshore wind and monitoring biodiversity, and which of the technologies do you think will predominate? PJ, maybe this is for you, but the others can jump in as well.
Yeah, I think, well, I think you saw from my presentation and also from the ones that followed, there are a whole diversity of techniques that are evolving very rapidly. But I think, and again, my papers, again, not to just keep promoting that, but there is an assessment in there of what will become, what is currently and likely to be in the short term, the norm in terms of methods. But I think in terms of trends, I think at the moment, digital aerial surveys are still very reliable for certain mammals and birds, partly because if you get a digital image, it's easier to use. I think over time, you'll see, at the moment, drones often don't have the range to go out to sea to do what aircraft are doing, but I think over time we'll see that change, and then more sensors be able to be deployed remotely. And as Peng very adequately showed, I think concisely and accurately demonstrated that satellites now, in the old days, it was just a question of you knew it was the sea, but now you can sometimes even detect species within that as well. So I think we'll get more satellite-based sensors as well. I think in terms of offshore wind in particular, I think we're already seeing it, but we'll get more and more sensors mounted on the jackets themselves, and we'll get more and more real-time monitoring. And that won't just be cameras, it'll be things like infrared, radar, LiDAR, and various other detection mechanisms as well. Because one trend offshore as well is the development of these multi-use platforms where you might in future more likely to see wind energy alongside solar energy and other activities like aquaculture and so forth as well. So I think you're going to get a mix, but I think the main trend is you will continue to see more and more combined methods with the technologies that become more cost-effective predominating. You'll probably see, at least for now, there seems to be an awful lot of faith in environmental DNA, but I think it's probably going to be less than people think. It'll play a role, but perhaps not as predominant as some people think.
I see some nodding. Are you all agreeing?
Yeah, sure.
Hello. Actually, I think that we need to use the multiple method. Actually, to tell the truth, I also do research on the eDNA, and I also use the LiDAR, use different remote sensing method to do research on the coastal wetland, not only in the Antarctica. So I think this era, we should not only depend on one method, we should combine the method together and with the target of our I think with the macro target of the biodiversity conservation. Yeah.
Thank you. I already see a note on this. eDNA works well for some groups, but not yet for others. So the risk is missing part of your ecosystem representation. So I think there's still a lot of room for discussion here. There are a lot of open details and questions, but the time is unfortunately over. And but I thank you all for joining and taking part in this very interesting discussion. If there are some open questions, please reach out bilaterally, and we can make sure that we can, you know, revert to the right speakers. I would really like to thank all of you for joining. It was very interesting, insightful. Please have a look again at the papers published, at all the links that we published. I just want to mention that we have another webinar next week on offshore wind in Australia. So who is interested in that, please join us for that. There will be an interesting discussion. It will be a presentation by Professor Sven Teske. So please take a look at this. And yes, looking forward to learn more about this, and I'm sure we will stay in touch. Thank you, Peng, for joining from China, because I know it's very late for you, so have a good night.
Okay,
for
thank
all the
you.
other ones, have a good afternoon, and looking forward to further cooperation. And please, if you have questions about GINGR, feel free to reach out. And thanks for all your engagement, and especially to the speakers for these great presentations today.
Thank you, Annika. Thank you, everyone.
Thank you very much. Thank you.
Everyone.
Bye-bye.
Bye-bye.
Bye.
Bye,
Take
bye,
care.
bye.